Okay, class. Assalamualaikum and good evening. So, for our lecture today, we are going to continue with chapter 6, still on chapter 6. Alright. During the last lecture, we have looked up until the cardiac cycle, okay, where you have to know what is cardiac cycle, okay, and what are the phases of the cardiac cycle. You have the systole and also the diastole, and then you have to also know that the average heart rate is 72 beats per minute. So it means that for a complete for a complete cardiac cycle, it will take about 0.8 second, which is divided into two stages. Okay, the phases of cardiac cycle. Okay, so these are the stages of the cardiac cycle of the 8 total second, 0.8 second of the cardiac cycle too. So you have to know what happened. Okay, what happened during these 3 stages of the cardiac cycle. You have to know what happened to the atrium chamber. Okay, what happened to the ventricle chamber, what happened to the valve, okay, to the valve of AV valve, and also semilunar valve, okay, semilunar valve, okay, in each of these stages of the cardiac cycle. And then the last one, we looked at the heart sound, which is the lap dub. Okay, so and then so for today's lecture, we are going to look at the conduction system of the heart, where it involves the generation of the electrical impulses that is generated by the cardiac muscle itself. Okay, and this electrical impulse will travel through the cardiac muscle and causing the cardiac muscle to contract and then relax. Okay, so if you look at this, it says here contraction of the heart is initiated by the pacemaker. So that is a specialized autorhythmic, which is spontaneous, okay, by the cardiac muscles, by the cardiac muscle cells. So you have here a specialized tissue, okay, within the cardiac muscle. We call it as the sinoatrial node, or the SA node. So the SA node is located here. Okay, so this diagram I added in this slide. Okay, so you can also refer to the same diagram in the next slide. Okay, so you have to know the position of the SA node, which is also known as the pacemaker, where the original electrical impulse, the initial electrical impulse will be generated that causes the heart to contract. Okay, so the SA node is located in the upper wall, okay, upper wall of the right atrium. That is the location of the SA node that you must remember. And then the SA node will set the rate and timing of the cardiac muscle cell contraction, and then electrical signal from the SA node pass freely and rapidly through gap junction. So as you can see here in this diagram, you will see the cardiac muscle cell. So one cardiac muscle cell to the next cardiac muscle cell is connected by gap junction, desmosome and also gap junction. Okay, desmosome and also gap junction. So desmosome kita tengok sem lepas kan, dengan gap junction we looked at during last semester and also the previous chapter, where in the transmission of impulse from one cell to another cell, especially that involve the cardiac muscle, the transmission of the impulse, the transmission of the electrical impulse involve ions, okay, to flow through the gap junction, which is the cytoplasm of one cell to another cell is directly connected. Okay, so this will cause the ion to flow rapidly from one cell to another cell in transmitting the impulse. So this is known as it involves in the electrical synapse actually. Okay, electrical synapse to allow very rapid transmission of impulse. So this gap junction, you can that involved in the rapid transmission of impulse is involved in the cardiac muscle and also in the brain. Okay, for rapid transmission of impulse, electrical impulse. So electrical signal, same as electrical impulse, okay, from the SA node passes freely and rapidly through gap junction into the connecting cardiac muscle cells, and then throughout the atria. So from the SA node, so the electrical impulse will travel through the wall of the atrium and causes the atrium to contract. Okay, and this impulse will reach the next node, which is the AV node, atrioventricular node. Okay. So that's the next node. Okay, the atrioventricular node again. So you have to know the location of this node. So the atrioventricular node or the AV node is located between the wall of the right and left atria. So specifically, it is in the floor of the right atrium. Okay, here. Okay, so the impulse will travel from SA node to the wall of the atria until it reaches the AV nodes. When the impulse reaches the AV node, there will be a slight delay. Okay, a slight delay as the impulse reaches the AV node. So the purpose of this delay is to allow the atria to completely contract and causes all the blood from the atria to enter into the ventricle. So this is the important point that you have to know as to why there is a slight delay of the transmission of the impulse as it reaches the AV nodes. So the reason is here. Okay, to allow the atria, both of these atria, to contract fully and causes all the blood in the atria to enter into the ventricle. So from the AV node, it then travel into the atrioventricular bundle here. Okay, so this is the atrioventricular bundle. Can here, this one here. All right, and then the AV bundle is also known as the bundle of His. Okay, bundle of His. From the bundle of His, it branches. The impulse will travel through the AV bundle branches. Okay, AV bundle branches. So these AV bundle branches will branch. Okay, to the right and left branch. Okay, left and right bundle branches to the base of each of the ventricle base. So from AV to bundle of His to bundle branches and to the base of the ventricle. So the base of the ventricle here is known as the apex of the heart. Okay, apex of the heart. Okay, so from the apex of the heart, from the base of the heart, then the impulse will travel up through the ventricular wall. Okay, which involve the Purkinje fibers. Okay, so the Purkinje fibers will spread in the wall of the ventricle. Okay, so Purkinje fiber at the base, it says here, from the Purkinje fiber, for the Purkinje fiber, at the base, bundle branches separate and give rise to Purkinje fibers, transmitting impulses to the surrounding cardiac muscle. Okay, which is specifically in the wall of the ventricle. So causing the ventricle to contract from base upward. Okay, from base upward or from apex of the heart upward. Okay, upward. Okay, so the contraction of the heart, especially at the ventricle, it needs to start contracting from base upward. Okay, from the apex upward. Why? Because this is to push the blood in the ventricle out of the heart. Okay, which the blood will move. Ini into ventricle balik kan. Okay, so the ventricle needs to contract from apex upward. Why? Because the blood vessels, okay, the blood vessels are located at the top of the heart, which is the aorta and also the pulmonary artery. Kalau hari tu kita belajar kan, kalau right, okay, this one is right. Okay, right ventricle, darah akan keluar ke pulmonary pulmonary artery ke lung kan. Tapi kalau left ventricle, dia akan pump blood out of the heart through the aorta kan. So kedua-dua ni aorta and also pulmonary artery, kedudukan dia ada pada atas jantung. So the contraction of the ventricle has to start contracting from apex, from base of the ventricle upward. So this is to push the blood out of the heart into the aorta and also into the pulmonary artery. Okay. So pulmonary artery into the pulmonary circuit, aorta into the systemic circuit. So itu akan kita tengok balik lah yang blood circulation. Okay. So the heart pacemaker and its connection. Okay. So this is the whole heart diagram, the bigger picture. Okay, so you have the heart, and then it shows you the location of the SA node and also the AV node. From the AV node into the AV bundle, okay, which is bundle of His, and then bundle branches, and then down into the apex of the heart, and then up to the Purkinje fibers. Okay, so that is the flow of the impulse. Okay, so you have to know how the impulse travels, okay, from SA node known as the pacemaker through the atrium wall, causing the atrium to contract, pushing the blood into the ventricle. Okay, so there will be a slight delay at the AV node, so that the contraction of the atrium, this is to make sure all the blood in the atrium is it enters into the ventricle. Okay, to make sure that the atrium finish contracting to push all the blood into the ventricle. Then the impulse will travel through the bundle of His and then bundle branches, and then to the apex of the heart, and then up to the Purkinje fibers surrounding the ventricular wall. Okay, so that is conduction system of the heart. Okay, so how the impulse travels along the heart muscle, the cardiac muscle. So next is the electrocardiogram or the ECG. Okay, right. So the electrocardiogram, the ECG or EKG, so this is the definition. Electrocardiogram, it is a record of electrical impulses that travel through heart muscle during cardiac cycle. Okay, cardiac cycle. So cardiac cycle kita tengok, it consists of the moment where the atrium diastole dulu kan, ventricle diastole, and then systole contract. Okay, so through electrocardiogram you can see the trend of the electrical impulse. It is a record of electrical impulses that travel through heart muscle during cardiac cycle. So recording is taken by placing electrode at different location on the body surface. So this is the result, okay, of the electrocardiogram for one cardiac cycle. Okay, for one cardiac cycle during cardiac cycle. So you have here is the P wave. Okay, so P wave indicates atrial contraction or atrial systole. Okay, atrial systole. So you can see, so the electrical impulse, the electrical reading will have a higher value here. Okay, and then after the atrial contract, so next is ventricle contraction. Okay, which is the QRS. Okay, as you can see, the value is higher because the contraction of the ventricle will generate more electrical impulse, obviously, because the wall is much more bigger compared to the atrium. Okay, so QRS complex shows ventricular contraction. So you have to know each of these waves. Okay, each of these P wave, QRS complex, what happened. Okay, and then after that, after the ventricle contracts, systole, and then the ventricle needs to relaxation. There's still readings of electrical impulse still. Okay, T wave indicates ventricular relaxation. Okay, so for this slide, it gives you what happened at each of the reading of the ECG. Okay, so the first one, the yellow region here, Okay, as you can see, it shows you that the signal, okay, or the electrical impulse, the yellow colored region, okay, the signal, the yellow colored region spread from the SE node, sinoatrial node, through and then spread through the atrium wall, okay, so and causes the atria to contract. Okay, atria contract or atria systole, and then as the atrium contracts and push the blood into the ventricle, there will be a slight delay. So ada macam a straight line there. Okay, so it shows you that there is a slight delay at the AV node. Okay, the signal will be delayed slightly at the AV node. This is to make sure again that all the blood in the atrium enters into the ventricle. And then after that, this region here, okay, of the ECG indicates the bundle branches passes signal to the apex of the heart. Okay, so from AV nodes to a bundle of His, okay, to bundle branches, and then to the apex of the heart, the base of the heart, and then baru dia menghasilkan complex QRS ni. Okay, that shows the contraction of the ventricle. So the electrical impulse will spread through the Purkinje fibers, causing the ventricle to contract. Okay, to contract. Okay, so you have to know this graph, the ECG graph, what happened at P waves, at QRS complex, and also at T waves. Okay, so comparison between normal and abnormal ECG. So this is the normal sinus ECG. Okay, normal sinus rhythm. Okay, so this is the normal heartbeat. Okay, so you can see all the waves and QRS complex forms nicely. So you have kita tengok kat sini lah, start pada sini lah. Okay, you have the P wave, the QRS complex, and then the two waves, and then they repeat balik kan. So the P wave, the QRS complex, and then the P waves. So repeat lah for the entire heart rate. Okay. And then for the second diagram B, okay, junctional rhythm. So the SA node is non-functional. So SA node is non-functional. P waves are absent. As you can see, there is no P waves here. Kan, tak ada P waves. Okay, absent, and heart is paced by the AV nodes. Okay, so it means that the impulse, okay, the impulse is generated by the AV nodes, okay, which is causing the heart to beat slower, okay, at 40 to 60 beats per minute. And then you have the third diagram. See here, second degree heart block. Okay, so some P waves are not conducted through the AV nodes, hence more P than QRS wave. You can see that there's more P wave here. Okay. Sini satu kan. Okay. More P waves. Okay, more P waves compared to the QRS complex. So the ratio between P and QRS waves is 2:1. 2 P waves to 1 QRS complex. Okay. And then for the fourth diagram, it shows you ventricular fibrillation. This chaotic, grossly irregular ECG deflection are seen in acute heart attack and also electrical shock. Okay, so this the comparison between normal and abnormal ECG. Okay, so next is the cardiac output. Okay, so the definition of the cardiac output is the volume of blood pumped by each ventricle per minute. Okay, so kita tahu dalam 1 minit your heart will beat about 72 beat per minute, your heart rate. Okay, so how much in 1 minute does your does your heart pumps blood? Okay, in 1 minute, how much of the blood is pumped out by the heart. So that is cardiac output. The volume of blood pumped by each ventricle in one minute. So there are two factors that will influence the cardiac cycle. One is the heart rate. Okay, so what is heart rate? The number of heartbeat per minute. So the average is 72 beats per minute for a normal healthy person. 72 beats per minute. Okay, and then the second factor that determines the cardiac output is the stroke volume. So what is stroke volume? The volume of blood pumped by a ventricle in a single contraction. Satu denyutan jantung tu, okay, berapa banyak darah yang dikeluarkan oleh ventricle. So that is stroke volume. Satu stroke kan? Satu stroke, berapa banyak darah yang ventricle keluarkan. So that is stroke volume. So for average stroke volume, it is about 70 milliliter per beat. Satu stroke, 70 mililiter darah yang keluar daripada ventricle tu. Okay, satu stroke. So therefore, for cardiac output, so how to get cardiac output? It is stroke volume, berapa jumlah darah yang keluar kali dengan heart rate. Macam tu kan. So kalikanlah, so 70 kali 70 mililiter per beat kali dengan 72 beat per minute. Okay, so ini mati kan. So jadinya kalikanlah 70 kali dengan 72, dapat berapa tu beat exact? Cuba kalikan. Do you get this volume? Dapat tak? Kan. So the average cardiac output is about 5 liter per minute. Okay, that is the amount of blood. Okay, the total amount of blood for an average person. Okay, the average volume of blood. Okay, in your whole body, which is 5 liter. So maksudnya dalam 1 minit tu punya jantung boleh pump the whole blood in your body. Okay, so the average cardiac output is about 50 liter per minute. It is about equal to the total volume of blood in the human body. Okay. Okay, so regulation of stroke volume. Okay, so kita nak tengok sekarang ni faktor-faktor yang mengawal atau menyumbang kepada stroke volume ni. Berapa banyak darah yang dipump keluar oleh ventricle per beat tu. Okay, so stroke volume depends on venous return. Okay, what is venous return? Venous return is the amount of blood entering the heart from the vein lah. Kan kita ada inferior vena cava and superior vena cava kan. So how much blood that returns back to the heart from the vein. Okay, so that is venous return. Okay, so that affects the stretching of the cardiac muscle. So venous return is the amount of blood entering the heart. Anything that increases the volume or speed of venous return increases the stroke volume and force of contraction. So the factors, that affects the venous return, okay, one of it is exercise. Okay, exercise. So exercise increases the venous return. Okay, if you exercise, so this will cause more blood to return to the heart, because when you are exercising, your muscle contract rapidly, and so this will return more blood to the heart. Okay, so increases venous return caused by the enhanced squeezing action of the active skeletal muscle, and then so therefore the stroke volume also increase. So buat exercise, pergerakan banyak kan, skeletal muscle contract rapidly, so this will cause more blood to return to the heart, more blood enter into the ventricle, so therefore when the ventricle contract, so more blood will be pushed out of the heart, so more stroke volume lah, so stroke volume increase. So therefore this enhance the cardiac output. It causes the cardiac output also to increase. Obviously lah kan. So bila stroke volume increase, obviously cardiac output also increase. So this is why, because to supply more blood, because more blood will carry more oxygen, more glucose, okay, to the exercising muscle cell, the muscle cell that is respiring actively, okay. So glucose acts as fuel for cellular respiration to generate energy, which is also required during cellular respiration is the oxygen. Kita belajar dulu kan, cellular respiration perlukan glucose, perlukan oxygen in order for cellular respiration to generate ATP, okay, to provide your body with more energy. So it says here low venous return might result in several blood loss, kan. So if a person experiencing blood loss, so obviously venous return will be reduced, okay. Okay, so next, okay, so the pacemaker is regulated by two portions of the nervous system. So the nervous system will have is called it has two division, okay, two division, which is the sympathetic division and the parasympathetic division. Okay, so that is the nervous system. So the pacemaker is regulated by two portions of the nervous system. So for the sympathetic nervous system division, so this involves your body to pump more blood. So your heartbeat will pump faster. Okay, so for example, during physical and emotional stress, okay, sympathetic nerves. So during times of physical and emotional stress, so the nerves of the sympathetic division will stimulate the SA node and also the AV node to increase the heart rate. So that is one condition, okay, that causes the heart rate to increase. Physical and emotional stress. Physical macam tadi lah, you are exercising for example, okay. So next, when standing up and walking, okay, so when you are standing up and you start to walk, so obviously your heart needs to pump faster, okay, increase the heart rate, that is. So the sympathetic nerves increases the heart rate to enable the circulatory system to provide the additional oxygen needed by the muscle. Yang hari tu lah punya eksperimen exercise hari tu kan. So before and after, obviously you will have difference in the results, okay, before exercising and after exercising. Obviously the heart rate will be different. Before, the heart rate will be slower, and after your heartbeat will be faster. So this is this involves the sympathetic division, causing the heart rate to increase. So the next division is the parasympathetic nerves, okay. So yang ini untuk slow down the heart rate, okay, slow down the heart rate. So this is during physical and emotional relaxation, or rasa tenang ataupun you are at rest, for example. So the parasympathetic nerves stimulate the SA nodes and also AV nodes to slow and steady the heart rate. Okay, so example when you are sitting down and also dalam keadaan yang relax lah. So the parasympathetic nerves decrease the heart rate to conserve energy. Okay, and yang first one to use energy lah, and the second one is to conserve energy. Okay, so next, the pacemaker is also regulated by hormones and temperature. Okay, so these are the factors that influences basically later the heartbeat, the heart rate. The heart rate and the heartbeat is the same, the cardiac output, okay. So the pacemaker okay is also regulated by the hormone and also temperature. So hormones such as epinephrine ataupun adrenaline and also thyroxine stimulate the SA node to increase the heart rate, okay. So kita belajar kan hormon epinephrine ni, which is released when you are feeling excited, dalam fight or flight tu kan, your body needs instant energy. So it also causes your heart to beat faster, to circulate more blood throughout the body, okay. So this the hormone will influence the pacemaker to generate more impulse, okay. to cause more heart rate, increased heart rate. And then another factor that that influence that influence the pacemaker is the physical factor. Okay, physical factors such as age, gender, exercise, body temperature also affects the heart rate. So age, so as you age, the older the person, the heart rate will reduce. Okay, so heart rate decreases as age increases. Okay, so gender, women have a higher heart rate compared to men. Okay, and then exercise increases after the heart rate. And then lastly, body temperature, heart rate increases as body temperature increases. Kalau kita demam, suhu badan kita pada normal, okay, normal 37, kan, 37 yang sebelum demam. Okay, kalau if you have a fever, okay, for example 38, your body temperature increase to 38. Kalau normal heart rate tadi 72 beats per minute, kan. So 1 Celsius increase, okay, 1 Celsius increase in body temperature causes the heartbeat to increase by 10. Okay, setiap 1 darjah Celsius suhu badan awak naik, dia akan meningkatkan heartbeat by 10. So maksudnya kalau suhu awak 38 degree Celsius, your heart rate will be 82, for example. Kalau 39, for example, 39 degrees, so increase by another 10. Okay, so that's why you don't want your body temperature to increase above 40. Okay, so kalau especially kalau kanak-kanak, kalau budak, kalau baby, you don't want you need to monitor the body temperature, especially for children having fever. Jangan biarkan kanak-kanak suhu badan meningkat kalau dia demam. Dia boleh menyebabkan sawan macam tu. Okay, you tak boleh. Jangan biarkan kanak-kanak demam dengan suhu yang tinggi. So pastikan kalau awak ada adik-adik yang demam ke whatever, buka baju dia, tuam dengan air, buka kipas laju-laju. Do not let the body temperature increase above 40 degrees Celsius. Okay, kalau dah 38, 39 dah tinggi dah. Okay, for children especially. Okay, mandikan dengan air macam tu kalau demam. Okay, okay, so saya tengokkan selalu kalau macam ada orang post gambar baby demam ke whatever, saya still tengok ada yang, sebab baby kan, baby kita punya culture mesti nak pasangkan sarung tangan ataupun stokin. Kalau demam, make sure jangan pasangkan stokin ataupun sarung tangan. So biarkan haba tu keluar daripada badan. Okay, so next is irregular heartbeat or arrhythmia. Okay, arrhythmia. So arrhythmia is a problem where the rate or rhythm of the heart. Okay, a problem with the heart rate. Okay, heart rate or heartbeat. So it means that the heart either beats too quickly, really fast, too slowly, okay, or with irregular pattern. Okay, irregular pattern. So we have two conditions here: bradycardia, which is referring to the slow heart rate. Okay, slow heart rate. Brady slow. So the heart rate will beat slower than 60 beats per minute. Kalau normal tadi 72 beats per minute, kan? Tapi kalau bradycardia, the heart will beat slower, which is below than 60 beats per minute. Okay. And then the factor could be due to low body temperature, parasympathetic nerve action, or certain drugs. So persistent bradycardia could cause inadequate blood circulation to body tissue and often a warning of brain edema or head trauma. Okay, so you don't want your heartbeat to consistently beat at really slow rate. Okay, so that is not good lah. Okay, so it causes less blood circulation. So and then the next condition is tachycardia. Okay, tachycardia is the opposite, where the heart beats faster, which is more than 100 beats per minute. So factors could be increase in body temperature, macam saya cakap tadi kan. So you don't want your body to increase above 40 degrees Celsius. And then stress, okay. If you are feeling stressed, obviously you can try and take your heart rate. So you will find that your heart will beat faster. And then heart disease and also certain drugs. So persistent tachycardia leads to cardiovascular disease. So it promotes fibrillation, which is a local uncontrollable twitching of the muscle fibers. So as you can see, the ECG, so there will be more peak, kan. Kalau tengok kat sini, you see more of the QRS, okay, QRS complex tu. Kalau ini nampak jarak sangat. Jarak-jarak kan. Okay, so that is irregular pattern of the heartbeat. Okay, so we have bradycardia and also tachycardia. Brady is slower heart rate, tachycardia is faster heart rate. Okay, so next is the cardiovascular disease. Okay, so cardiovascular disease is disorder of the heart and the blood vessels. Okay, disorder of the heart and the blood vessels. Number one cause of death in human worldwide. Okay, so factors contribute to cardiovascular disease is age. So as people age, their blood vessels lose elasticity. And then inactivity or passive, tak bergerak, malas, semua kan. So that leads to obesity. And also can be due to genetics, tobacco or isap rokok ke, and then poor diet. Okay, makan banyak lemak, tak makan sayur, whatever, kan. So that is poor diet. Okay. So and then so arteriosclerosis. Okay, what is arteriosclerosis? It caused by the build-up of fatty deposits or plaque within the tunica intima of artery. Kita belajar kan, itu lapisan blood vessels. The tunica intima is the inner lining kan. Kat sini the inner lining is the tunica intima. So there is a build-up of fat deposit here, okay, or plaque, okay. So arteries become less elastic and partially narrowed, leads to endothelium damage and weak walls. So you have the artery, so they start dengan fatty deposits, okay, which form plaques, and then the plaques will grow, and then it leads to the rupture of the plaque and then causes blood clot to form. Sebab rupture kat sini dia macam trigger punya immune system yang ada macam kecederaan kat situ. So nanti akan ada platelet datang, so dia akan form macam blood clot kat situ, okay. So blood clot. So this blood clot dia boleh block lagi the blood vessels, ataupun dia boleh loose daripada kawasan ni and travel to other blood vessels and block other blood vessels. Macam tu, okay. So mechanism of arteriosclerosis, okay. So excess cholesterol leak from lipoprotein, so and then deposited on the arterial wall, macam ni lah kan, deposited on the arterial wall, and then akan ada satu jenis white blood cells which is initially monocyte kan, monocyte, dan dia akan convert into macrophage. So macrophage, so these white blood cells will trap within the cholesterol. Saya tengok tadi kan, ada video kat dalam YouTube, saya just nak cuba fahamkan. So macrophage ni sebenarnya dia akan engulf the cholesterol, okay, engulf the cholesterol molecule, and then dia akan jadi sejenis sel, kita namakan dia form cells kat situ kan. Sudah ada berlaku satu mekanisme kat situ, and then releases free radical which damage the arterial wall and causes, yang tadilah akan menyebabkan boleh berlaku rupture of the plaque, okay. So activate blood platelets stick to the damaged area, releasing clotting factor, okay, clotting factor, thromboxane, okay. So dia akan, in this lead, the rupture of this plug, okay, causes blood clot to form. Okay, blood clot to form. Okay. So form a plug which may rupture to produce thrombus. Circulating thrombus is called an embolus. So the embolus may lodge elsewhere in the blood circulation. It can reach the brain, the heart, arteries also. Okay, so you can search in the YouTube. Ada banyak video yang dia explain on how atherosclerosis occurs. Okay. Okay, so next is hypertension or high blood pressure. So systolic pressure. Okay, so systolic pressure is above 140 millimeter mercury. Okay, so systolic. Kalau normal, for a normal systole, dia tak tulis kat sini. Okay, normal systole should be 120. See, this is the normal blood pressure. The normal blood pressure, systole 120, diastole 70. Okay, for a person with hypertension, okay, systole bacaan dia lebih daripada 140. Beza tak? Asal 120, 70. Systole 120, diastole 70. Tapi for a person that have high blood pressure, hypertension, the systolic reading will be 140. Bacaan atas dia 140, bacaan bawah dia about 90 macam tu. Okay? So beza kat situ. So this hypertension or high blood pressure is directly connected to cardiovascular disease. Okay? That leads to it can contribute to heart attack and also stroke. Okay. Okay, so that is hypertension. Increase wall thickness. Okay, increase wall thickness. So ini normal healthy blood vessels kan. So tak ada formation of plaque whatever. So this can be due the first blood vessels can be due to the formation of plaque kan. So it narrows the blood vessels and causes high blood pressure. Okay, so that is high blood pressure. So kalau normal 120 over 70, kalau hypertension above 140 over 90. Okay. Okay, so hypertension or high blood pressure can be controlled by you change your way of eating. Okay, daripada suka makan benda yang berlemak je, tukarlah jadi makan lebih banyak buah ataupun sayur contohnya. Okay, exercise. Okay, jangan pasif je duduk macam tu kan. Makan tidur. Okay, so you have to exercise and also meditation. Tapi ada juga orang yang dia dah kawal dah dia punya diet. Dia dah makan sihat, seimbang. Dia seorang yang aktif. Tapi still dah ada high blood pressure. So this can be contributed by genetic factor. Contohnya keturunan. Memang dalam keturunan dia ada high blood pressure. Macam tu. Okay. Okay, so terminologies in cardiovascular disease. Okay. Saya nak bagi contoh yang ni kan. Contohnya, kalau saya bagi contoh, for instance, ayah saya. Dia seorang yang kurus satu. Dia tak gemuk pun. Dia seorang yang sangat aktif. Dia sangat jaga makan. Okay, dia sangat jaga makan. So, dia pergi check up. Okay, dia pergi check up and then he found out yang ada one of the major blood vessels dia ada start untuk one of dia punya artery dekat jantung, yang major artery ada blockage. Macam tu kan. So memang dalam keturunan ada high blood pressure. Okay, macam tu. So tengoklah kan. So kalau dah ditakdirkan awak ada penyakit tersebut lah, kena ni lah, kena terima. Okay. Walaupun dah makan, dah exercise, sangat aktif kan. So itulah dia. Okay. So and then some terminologies, myocardial infarction or heart attack. Okay, so damage or death of heart muscle tissue caused by blockage of one or more coronary artery. Okay, and then angina pectoris, chest pain caused by partial blockage of coronary arteries. And then stroke. Okay, stroke, which is death of nervous tissue in brain, usually caused by rupture of blockage of artery in the head. Okay, so itulah dia. Okay, so just take care of your heart lah. Okay, nak macam tu. Alright. So the next part is blood pressure lah. I guess kita nak sambung tak? Sambung kot sikit lagi. Okay, so blood pressure. What is blood pressure? It is so blood pressure is the pressure of blood against the wall of blood vessels. Okay, so the pressure of blood, your blood that flows in your blood vessels, they have pressure. Okay, they have pressure, which is the pressure is generated by the pumping of the heart. Okay, so as the blood flow with pressure, so the pressure will be pushed against the blood vessel. So darah yang mengalir tu dengan high blood pressure, dia akan menyebabkan pressure pada wall of the vessels tu. Macam tu, okay? So systolic pressure, okay, is the pressure in the artery during ventricular systole. Ventricle systole contract, it pushes the blood out of the heart with high pressure. Okay, so this blood that enters into the artery, it enters with high pressure. Okay, so and then diastolic pressure is the pressure in the artery during diastole. Ventricle relax, darah yang mengalir dalam blood vessels pun mengalir dalam pressure yang menurun macam tu kan. So tapi dia your heart is pumping kan, so ada macam peak lah, peak and then turun, peak and then turun. Okay, peak and then turun lah. So that is systole and diastole. Systole and diastole. Okay, so that is the pulse. Okay, a pulse is the rhythmic bulging of the artery wall with each heartbeat. Can contract, relax, contract, relax. So thus it creates pulse, your pulse. Okay. So it indicates the rate of the heartbeat. So pulse rate yang awak ambil hari tu dalam eksperimen 4 hari tu kan. So your pulse rate is the same as the heart rate. Okay. So a good indication of a person's circulatory system can be obtained by taking arterial pulse and blood pressure measurement. So sebab kita restricted, kita ODL semua, you can only take your arterial pulse. Tapi kalau secara normal kan, kalau kita boleh masuk lab, kita akan boleh guna an equipment that can measure your blood pressure, which is here. Okay, sphygmomanometer ni. Dan awak akan guna stethoscope. Itu kalau kita masuk lab lah. Okay, so you should be able to learn, okay, how to take blood pressure using sphygmomanometer and also using a stethoscope. Okay. So as you can see here, is a graph showing blood pressure in different blood vessels, starting from the aorta into the arteries, arterioles, blood capillaries, venules, vein and also vena cava. Okay. So kalau tengok darah yang masuk ke dalam aorta, tengok dia akan flow with the obvious reading of systole and also diastole. Okay, yang peak ke atas ni, it shows you the systolic pressure. Systolic pressure normally for a normal healthy rich person is 120. So as the ventricle relax, okay, so the reading of the blood pressure will drop. That is the diastolic pressure. So systole, diastole kan, heart contract and relax, contract and relax. So this will exert pressure also to the wall of the blood vessels. Okay, but as the blood flows from aorta into artery, you will see that the blood pressure will start to reduce lah, sebab dia dah lagi travel jauh daripada jantung. So obviously the blood pressure will be reduced up until it reaches blood capillaries. Obviously dia akan drop sebab apa? Ada capillary beds kan. So kita dah belajar hari tu. The bigger the surface area, blood capillaries ada bigger surface area sebab dia dia dah branch into many blood capillaries, so therefore the blood pressure also drops. Okay, so even drops further as blood enters into veins and also vena cava. Okay, so you can detect your pulse at 3 different arteries. Kan, kalau tengok cerita drama-drama kan, dia check orang tu dah mati ke belum at dekat sini kan, dekat sini pun ada. Okay, so that those are the 3 points of the pulse that you can detect kan. So yang paling common radial artery dekat sini, okay, and then branchial dekat bawah, kat siku atas dia kan, kat pelipat dengan ni, and then carotid dekat leher sini. Okay, cuba rasa ada tak semua orang your pulse? Kalau ada, alhamdulillah. Okay, so we stop to this slide. So kita akan sambung on Thursday how to use this equipment to take blood pressure. Okay, so saya nak remind sebelum kita end our session, as your presentation akan start minggu ni untuk kejap saya nak stop